The theory of trigonometry is essentially the unit circle and all the concepts that we're trying to develop. We don't all of a sudden just kind of move on from there. It turns out that the theory never really goes away. So that's good news too, because if there's something you were confused about, when it kind of pops up again, you might say, now it clicks. We are going to take the theory though, and we're now going to apply it to triangles. You're going to feel like now the next stop on the journey is the triangles of trigonometry. Okay, kids tend to like the triangles of trigonometry. Kind of a little more something you can like grab onto. You can kind of visualize a triangle. We will do some activities with triangles. Actually, we'll go outside, hopefully up to 3 times, and look for that. I'll give you a heads up. That way you can sort of prepare as far as maybe dress or something, but hopefully the weather's good and we'll go outside 3 times. That's kind of fun. And so we'll be talking about the triangles of trigonometry now for a number of weeks. Now, to start this, what I want to do is find my clicker thing. What I want to do is show you a problem that I don't want you to copy down, okay? But if you did kind of get your notes ready, great, because we're going to be in topic 2.1. But I'm going to show you something. Don't copy it down. The reason you don't want to copy it down is because, well, it's a segue problem. We're just trying to use this to segue into something new. And besides, you know how to do this problem. Based on the tests, we had good success with this problem. It's one of these guys. You've got a point, you've got basically an angle. You've got a point, you've got an angle. Now remember, we're going to take this problem, we're going to use it to kind of segue to something. So just go with me for a second. You would do what you did. You would make a sketch. Of course, you plot the point, you think about the angle, and then sooner than later, you make a triangle. Okay, now the triangle, of course, has legs, which are represented by that point. And so this, of course, is like the main thing. How about that other side, side R? Okay, you would find it, Pythagorean theorem, and out pops 15. Now, just as a little side note, and you don't need to copy this down, but as a little side note, this triangle is a special triangle in disguise. It's got an early Halloween costume. How good's the costume? What special triangle is in disguise here? Might be a pretty good disguise then. It's a special triangle. It just goes back to geometry, okay? It doesn't hurt to remember these things because you never know when it'll help you maybe tomorrow. This is a 3, 4, 5. The reason it's a 3, 4, 5 is because these numbers are all in that multiple. The disguise it's wearing is it's wearing a 3 because everything is by a factor of 3. Okay, so the triangle is disguised by a factor of 3, but it's really a 3, 4, 5. Okay, that's just a little extra information. Sine of theta. Okay, if you're kind of like, what do we do with this? You find a trig value, you find the sine. Now remember, the sine of theta is y over r, so 9 over 15. Cosine of theta is x over r, so 12 over 15. And then, of course, you have the tangent of theta. Okay, now, I get it. This is your first journey through trigonometry, but I'm trying to help you realize that these are more than just answers that you're trying to get on a test. These two in particular go back to a point, and it's on the unit circle, so it's probably about right there, okay, because the unit circle would be a lot smaller, but that point right there would be 9 over 15 and 12 over 15. It's actually really impressed how you answered that question on the test. Nice job with that. Okay, that's all old, okay? Let's talk about something new. Watch carefully, because what if the x and y axis disappears? What if the x and y axis disappears? It's interesting, isn't it? It looks a little different. Now you just kind of have a triangle that's not necessarily like locked in. It's just kind of a triangle. Would the sine, cosine, and tangent still be those fractions? Would the sine, cosine, and tangent still be those fractions? Okay, now, actually, I haven't told you, so if you're kind of like, I don't know, would they be? Right? Maybe you don't know. It's fine. That's kind of why I'm just presenting as a little bit of a question. The good news is they would be. The sine would still be 9 over 15. The cosine would still be 12 over 15, and same for tangent. So they would all be the same. Here's why. Here's why they would be the same, because these definitions are based on theta. Theta is an angle, and that angle hasn't changed. Okay? The truth is that angle actually kind of determines these sides. For example, this side right here, you've always known it to be the hypotenuse. What you're going to find in the next couple moments is that we're going to actually call it the hypotenuse. Okay? Now, you kind of already knew that. How about this side right here? Okay, it used to be side y. It used to be y. But now it's across from theta. Can you hear me even with the banging? Okay. Side 9, it's across from theta. Now, when we talk about something that's across from theta, we typically use a math word that starts with an O. We use a math word that starts with an O. It's not a tricky word. It's opposite. Now, I sort of wonder right now, are any of you having a little bit of a, oh, this? Maybe you feel like you've seen this before. Now, if you haven't seen it before, it's okay. You're in the right place. But yeah, this has kind of always been brewing. Okay, what's been brewing? Well, that these sides of this triangle can be named in a different way. We just need to name this side right here. This side right here is right beside. It's right beside theta. Okay, instead of calling it the side that's right beside theta, we have another sort of math word that we use. By chance, have you heard of it before? It starts with an A. Adjacent. Adjacent. Now, do you feel like that this might be something good to write down? Probably. So let me just pause and encourage you to, if it was me, I would get this triangle down, especially the words that we put on it. So again, I encourage you to sketch that triangle, especially the words. Make sure you put theta in the triangle. Theta. I had a young lady ask, and it's a good question. It actually usually comes up when I say theta. That's with a TH, not a F. So it's theta. Anyway, put theta in your sketch because the opposite side is across from theta. And then the adjacent side, it's beside theta. Now here's kind of the next thing, and honestly, this is really the thing. This is why we're doing this, because we still have the sine, cosine, and tangent. You will realize that we will always have those. That's trigonometry, okay? So look, sine, okay, 9 over 15, well, opposite over hypotenuse. So sine can actually be described now as opposite over hypotenuse. I won't say this every time, but have you feel like you've heard that before? It might be. Okay, and if you haven't heard that before, we're going to make sure you understand it. But sine is actually opposite over hypotenuse. Cosine, 12 over 15, adjacent over hypotenuse. Cosine would be adjacent over hypotenuse. And again, I see you guys doing this, which is a great idea. I would definitely write these down along with your triangle. And then you got tangent. Maybe you're thinking about it already, which would be great because tangent is 9 over 12. That would be opposite over adjacent. Tangent would be opposite over adjacent. These, I don't want to call them new. They're not really new. They still go back to the original unit circle, but we have kind of adapted the language. So the language we're using, okay, is still related to the theory that we did, again, in those first couple weeks. But you're gonna feel like that we now kind of talk about it this way, because basically the triangle is no longer on the x and y axis. The triangle can just be anywhere. I find that whether students have seen this before or not, still kind of the thing that, I don't want to say it makes the most trouble, but it still sometimes gets kids a little mixed up, is honestly just thinking about these three words. And so I'm trying to make a triangle that kind of purposely just looks a little different. It still has a right angle, and I'm going to put theta in it. All I'm trying to imply here is that we'll have a right triangle kind of turned in some way, but there'll be an angle, and still everything's based on that angle. In other words, whatever is across from that angle, and this, maybe you want to put it in your notes, try to make a little different triangle. Just another one to look at. Whatever's across from that angle, you must think of that as the opposite side. Maybe it seems kind of easy. We don't want it to be hard, but whatever's across from that angle is always the opposite. Whatever's beside that angle is the adjacent. The hypotenuse, that tends to not give people trouble. The hypotenuse, it's always the long side. It's always across from the 90. You know that. All right, well, let's do something with this. Let's solve a triangle. Actually, I have that as the title up here, but I want you to know when I say solve a triangle, okay, that is actually specific language, because it's asking you to find all the missing pieces. If I ask you to solve a triangle, we're asking you to find the missing pieces. You can write that down if you want to. I just want to make sure that you see that. Let's solve a triangle. Okay, when I say consider, usually I'm implying that there might be some things that you kind of know about this. Maybe there'll be something new. But let me give you a triangle and we'll talk about solving it. It's going to also involve a calculator. If you want to dig around and get a calculator, that'll be helpful. Okay, so things are kind of changing all of a sudden, but just kind of want to make sure everybody's comfortable with how I'll be presenting triangles. It's supposed to be the same way that you would have seen it in geometry, but essentially capital letters used to refer to the vertices and the angles. So capital letters, A, B, C, referring to the angles. The lowercase letters, now they are always connected to the angles. So since angle A is right here, side A, it's across from it, side A, lowercase a, this would be lowercase b, and then lowercase c. Again, same way you would have talked about a polygon in a geometry class. Okay, let me give you some stuff about this triangle. How about angle A is 49 degrees. Angle A is 49 degrees, and side A, how about, we'll know that that's 7. Okay, now the thing that's always kind of amazing about these problems, even though I see them often, but you might kind of say to yourself at some point, geez, that's not that much information. And yet, if I give you one angle and I give you one side, you'll be able to find everything else. That's kind of the cool thing about this trigonometry. And that's what we want to do. We want to find the rest of these dimensions. Now, before you jump in there sort of head first, it's helpful just to pause and think about the words, to think about the language. In other words, that this is theta. And that means the side that is opposite, well, obviously is the opposite, but the side across from that theta, we want to, if it was me, I probably would label that as opposite. And then the side that is b-sided, that's the adjacent. And of course, the hypotenuse. Now, maybe there'll be a time, I don't know if it's today or tomorrow, that you'll kind of feel like you don't need to write those words down. That's fine. Okay, I'm not going to like force you to do that, but definitely need to think that. So we have our triangle kind of set up here. Now, the other thing that's kind of weird here is that you got a couple things you need to find, and sometimes that throws kids off because, I mean, you got to realize that side B, you need to find. Side C, you need to find. And by the way, angle B, you need to find. And just because there's like so many things to find, sometimes people have trouble getting started. And I just want to say to you that you just need to pick something to find. And maybe you need me to suggest, or maybe you just decide to start with side B. Just hear me out. You could have started with side C. You could have started with anything, but you need to pick something to find. This is probably the most important thing that you'll hear today. And maybe some of you already understand it, but just still listen to it. Because if I'm going to try to find side B, I have to now do a careful analysis of my trig functions. Just take a look at this little phrase. It's meant to help you. We have to pick a trig function. We have to pick a trig function that uses the side that you know and that you want to know. Do what you want with this. It's there for you, but it's what you have to think. The side that you know and the side that you want to know. And just want to make sure that you're kind of ready to think about this, because a lot of times we think about this correctly the first time. Lots of things are going to go well in the next couple days. What side do we know? Just to make it kind of real simple and clear, we know the opposite. Okay, that's what we know. What do we want to know? What do we want to know? Well, since we decided to find side B, we want to know the adjacent. Okay, and again, now we get to the main thing. The main thing is to think about the words opposite and adjacent, and quite simply, which one of these trig functions over here uses opposite and adjacent. Okay, so we pick up the phone and we're going to call which trig function? We're going to call tangent. Okay, we're going to call tangent. Now, I'll say we're going to use tangent. I'm kind of writing down just a little bit of my thought process. It might be some extra stuff that you don't feel like you have to write down sometime, but I just want you to know we're going to use tangent because that's opposite and adjacent. For most of us, you need to write down how you're going to use it. And this is kind of the fun part. You're going to plug in. You're going to plug in 49. So, of course, we plug in 49 degrees for theta. We're going to plug in 7. So plug in 7 for opposite. And then, well, you don't have anything to plug in for the adjacent. That's your variable. I'll call it B. Some kids like to call it X, but it's a variable. It's your unknown. All right, and now we got ourselves a little equation. Okay, now listen, this is a little equation. You got to solve it. Depending on your algebra, kind of how you look at this. Some kids would cross multiply. It just kind of makes things easier for them. I'm going to choose not to really cross multiply, but I'm going to show that I could multiply by the variable, by the denominator. You definitely have to multiply by the denominator because we got to get it out of there. We got to multiply both sides by b. So we have b times the tangent of 49 equaling 7. Okay, now, again, some of the stuff I'm showing here, maybe you say, I don't know if I really need to show that. It's up to you. I'm just showing it for the first time for sure because we're solving for b. All you got to do is divide both sides. Divide both sides by the tangent of 49. Okay, and essentially you have solved that little equation. Of course, you're going to use your calculator to finish that, I encourage you to play along. Make sure that you're using your calculator correctly. But again, it comes out to be 7 divided by the tangent of 49. Get about 609. 6.09. We'll usually round to 2 decimal places. Just a nice, consistent standard. Keep everybody together. Any concerns? Anything with your calculator? Make sure it's in degrees. I don't know what you did last on it. Let's keep going. I'd like to talk about side C. A couple things about side C. Just to be honest, there's 2 ways you could find it. Okay, I'd like to show you the trig way. If for some reason you're thinking there's another way, yes, there's 2 ways to find C, but I'd like to just show you the trig way. Okay, because it gives us an opportunity to think again about this little know and want to know. Okay, know and want to know. I know the opposite. I want to know the hypotenuse. And by the way, you can see here that I'm going back to like the original information. So I know the opposite. I want to know the hypotenuse. Pick up the phone, and who are you going to call? Sine. Or Ghostbusters. You're going to call sine. Opposite and hypotenuse. So again, just to show you sort of my thought process here. Maybe that's extra and you don't feel like you have to write that, but there it is. We're going to use sine. Now look, we still kind of go back to like the original information. I'm talking about 49 degrees. It's the sine of 49. We're going to go back and use 7. It actually kind of looks like almost the same equation, doesn't it? Look, when you have an equation with the variable in the denominator, you're always going to solve it by dividing. You're always going to solve it by dividing, in this problem, 7 divided by the sine of 49. And as you can see, I'm kind of saying that that's fine. If you just want to set up the problem, okay, you do need to set up the problem when it comes time for like a grade, and then solve the problem. Use your calculator. Just saying, sometimes there starts to be confusion where kids aren't sure which way to divide. So you can go back and you can solve it with algebra. You will end up dividing the same way. Now look, we're going to find side C a different way. Try not to say, do I have to? I'm showing this to you for a reason. And the honest truth is that it might be necessary next time. It might be helpful next time. And maybe just appear simply to say, you're allowed to do this. Because side C, as you have always known, is the hypotenuse. And since we have a right triangle, the Pythagorean theorem is certainly still in play. What I'm trying to communicate is that you can use Pythagorean theorem. Now, I think we all realize that we're using a rounded number. We're using a number that we found. Mathematically, it's all fine, but 609 is rounded, and so we just kind of need to be aware that maybe the answer we get here has the potential to be a little rounded. But again, this is fine. You're allowed to do this. Okay, and when you... Same thing, I set up the problem. I solved the problem on my calculator. It turns out that we basically get the same answer to 2 decimal places. Thoughts on the sides. I'm going to give you a triangle to solve. A lot of kids like that, just give you a chance to try something. There is one more thing we should do here, but it really should be a freebie, okay? Angle B should be a freebie, but we do need to find it. How'd you get it?
90 plus 49.
Okay, so we kind of have that version. Okay, sometimes kids will say, well, I took 180 minus 90 minus 49. Oh, well, that's actually the same thing by algebra. And just saying 180 minus 90 will always be 90. So we could just do 90 minus 49. Not to overdo it, but there's a couple different ways to do it. 41. Okay, again, you got to find it, but it should kind of be a freebie. Just a side note here. Notice that I did that last, and I did that on purpose so that you wouldn't confuse the number 41 with using it down here. Okay, notice that I stuck with the original angle down here. It's supposed to kind of make it a little easier to stay kind of organized. Now, I want you to try one. Just kind of, by the way, there's no homework tonight. We're going to continue talking tomorrow. I know I'm going a little bit slowly, but that's on purpose. We are going to continue tomorrow because there's a little more to do. But before we do that, try this. Just kind of, where are you at? Maybe you're good. Maybe you're going to realize that there's something that you aren't sure about. Okay, still pretty straightforward. Basically, we've got the triangle. Tell you what, sorry if you were a little quick on the draw there. Just to mix it up a little bit. Okay, so we got ABC. Again, I kind of changed it up just a little bit, not a big deal. All right, so kind of the same. Here's an angle. Here's a side, 14. C equals 14. Kind of want to challenge you and encourage you. Can you solve this triangle? Can you find all the missing pieces?